Welcome, everyone. Today's a really cool topic. We're going to be talking about what happens when your race lasts longer than 90 minutes. So, essentially, if you look, when is glucose or exogenous glucose from the diet going to help performance? Well, one of the things that people have postulated is that it will help performance in those people who become hypoglycemic. So if you look at this graph here, you essentially see two carbohydrate groups, and you also see two placebo groups. And you see that the actual distance that or time that they were able to go before exhaustion. Notice that at the very bottom, you see where it says 50 milligrams per deciliter, or 3 millimolars of blood glucose. That level is hypoglycemic. And notice their performance drops. The other group, however, the group B placebo, if you notice, they did not go hypoglycemic and their performance was as good as groups A and B, which are the carbs. So again, take-home message. If you do go hypoglycemic during exercise, carbohydrates can be beneficial. But besides maintaining blood glucose, carbohydrates in greater than essentially 100 minutes or 90 minutes has a big time effect on skeletal muscle glycogen levels. So if you look here, look at the graph on the left. That's muscle glycogen in millimoles per kilogram. You have the placebo group, which is white. You have the carbohydrate group, which is dark. They both start off with the same exact glycogen levels at rest. Okay, and if you look at type 1 fibers, at 104 minutes, the carbohydrate had significantly more glycogen, and at 132 minutes, they still had muscle glycogen levels, and the placebo were completely exhausted. So that's kind of one of the key points to point out here, is that it does spare muscle glycogen levels. So what's the threshold amount that you need for an ergogenic benefit? The literature seems to point to a minimum of 20 grams an hour. I didn't say that was the maximum, I said a minimum. Because Fielding, for example, found 12 grams of carbs an hour didn't enhance performance. However, 22 grams did when given during a 4-hour cycling bout, followed by a sprint time trial. So, again, I think the main point is that there's a minimum dosage and an optimal dosage for performance. The next thing that we want to talk about is, what about the carbohydrate type? We could take in glucose, we could take in sucrose, maltose, a glucose polymer such as maltodextrin. Those seem to be oxidized at about 1 gram per minute. That means you could take in 1 gram per minute at a maximum. Galactose and fructose are about 0.5 to 0.6 grams per minute that you can consume. If you look here, what they're essentially doing is they're giving a dose response of glucose and looking at the rate of oxidation of carbohydrate. So what you're seeing here, you see carbohydrate ingestion on the x-axis, and on the vertical axis, you see essentially the exogenous carbohydrate oxidation. But what you notice is that it plateaus at around 1 gram per minute. So again, that supports the fact that 1 to 1.2 grams is all you can really take in for glucose and maltodextrin. However, the key thing to remember is this, though. As we talked about previously, you have different transporter mechanisms in the gut, okay, in the small intestine. And the transport mechanisms for for glucose are different than the transport mechanisms for sucrose, for example. So what they did in this study is they looked at the rate of glucose oxidation, and you will see down here first, I'm going to point this out on the graph. The glucose-only group, this is a group that essentially they were exercising 150 minutes, that's 50% of their maximal output. They were oxidizing about 1.06 grams per minute. Now that's consistent with the literature, and that's what you see there. However, if we look above that, a group that consumed glucose plus sucrose actually oxidized 1.25 grams per minute. So this suggests that a combination of substrate is probably ideal to optimize glucose oxidation. Intriguingly enough, carbohydrates ingestion of 1.8 grams per minute resulted in 0.8 grams oxidation of maltodextrin. However, it was 1.5 grams per minute when you have the combination of maltodextrin and fructose. Maltodextrin, again, is a glucose polymer, so it'll go through the same transporters as glucose, whereas fructose is going to go through a different transport mechanism. And you see that it also increases performance. So it's 2 hours of 55% VO2 max cycling, followed by 1 hour time trial and trained cyclists. So if you look at the placebo group, that's power output. The glucose group got an 8% increase in power output, but the glucose plus fructose got a 16% increase in power output. So let's sum this up. The night before, if we're talking about a race that's 90 minutes to 2 hours, it's long, but not super long, but it's still long. It all starts with the night before, okay? So the night before, and 3 to 4 hours before the event, I would go essentially low glycemic the night before, okay? Because what studies have shown is that you become metabolically inflexible when you have high glycemic index carbohydrate the night before. And 3 to 4 grams per kilogram of a high to moderate carbohydrate 3 to 4 hours before to top off glycogen stores. Again, this is for a race. Now, 50 to 60 minutes before a race, if you're sensitive to hypoglycemia and things of that, or rebound hypoglycemia, have about 30 to 60 grams of low GI if you're consuming it 30 to 60 minutes before. However, 15 minutes before, you could have a moderate to high because your chances of going hypoglycemic are less. And then finally, during exercise, 30 to 60 grams an hour of a glucose polymer is fine for a race this short. However, if it actually goes past that time, like greater than 2 hours, then the night before, you do the same thing, low glycemic carbs before, 4 grams per kilogram, 3 to 4 hours before, and then 15 to 60 minutes before exercise. If 60 and you're sensitive to rebound hypoglycemia, I'd go 30 to 60 grams low. If 15 minutes before, again, I'd go moderate to high. This won't matter as much because of the counter-regulatory response. And then during exercise, now your performance is going to be enhanced by oxidizing more carbs because the race is so long. So you can have up to 60 to 90 grams an hour, and it should be a glucose polymer fructose mixture. That's like, for example, Gatorade, Powerade, most of those. As far as recovery, how do we optimize recovery? Well, we've talked about meal timing in our first carbohydrate lecture, so I'm going to skip past that. And we're going to go ahead and talk about meal frequency. So this study essentially gave 10 grams per kilogram of carbohydrate after exhaustive exercise over 4 versus 16 small meals. So if you look at table 2, you see the muscle glycogen concentration immediately after prolonged exercise and after 24 hours of nibbling. Okay, so the gorging was 4 meals to nibbling with 16 small meals. What you notice is that there's no significant difference at 24 hours between the rate of glycogen resynthesis here, between the nibbling and the high frequency group. This is very paradoxical because if you look at the gorging group in the right graph at the top, you see glucose levels are higher when they gorge, and if you look at the right graph bottom, insulin levels are higher in the gorging group than the nibbling group, which we think would augment muscle glycogen resynthesis, but it did not in this case. This has been supported by past research. In fact, classic study by Costel depleted individuals, and they gave them 7 meals versus 2 meals, same amount of carbohydrate. If you look at the graph, glycogen replenishment was not significantly different between the 7 and the 2 meal group. As far as glycemic index, one thing you want to know is that you need a low to moderate glycemic index, or when we're talking about low to moderate glycemic index, you need to know that high does seem to increase muscle glycogen stores more. So if an individual is glycogen loading or needs quick recovery, high glycemic may be the way to go, moderate to high. If not, low to moderate is adequate because you're also concerned with body composition and being able to maintain your focus throughout the day. Now, one of the things to look at here is this is looking at this graph, this study by Ivy. Essentially, they looked at the percent recovery of depleted muscle glycogen over a 4-hour period when you had to the left of the graph carbohydrates plus protein, then the right of that high carbohydrate, okay, and then a low carbohydrate. Now, what's interesting is that the carb plus protein had 80 grams of carbs over that 4-hour period, okay, plus they had 30 grams of protein. So what's real interesting is, again, the carbohydrate plus protein group got a better glycogen repletion response. We think that might be related to the ability of protein to augment the initial insulin response. So again, it's very, very important. This is another study looking at carbohydrate versus carbohydrate plus protein. You know, if you're not going to have a super high amount of, if you're not going to have a protein, you're going to need a super high amount of carbohydrate. So basically what you're seeing in this graph is carbohydrates at 0.8 grams per kilogram, and then 0.8 grams per kilogram plus protein, and then essentially 1.2 grams per kilogram. So very, very high carbohydrates can be beneficial. It's just that if you're not interested in that, or you're interested in body composition, the combination with that and protein is probably ideal. And that's the end. Thank you.